Hello, this is Matt Montgomery, sales agronomist with Burris. We're going to talk about a little different topic in our new series here. We're going to talk about sulfur. This is the first part of an 8-part series. We're going to try to answer some of the questions people have about this important nutrient. So let's outline the series for you. In session 1, we're going to talk about basic information, the series theme, and how sulfur enters into the soil cycle. Session 2, we'll talk about plant availability of sulfur. In sessions 3 and 4, we'll talk about plant available sources, both major and minor. After that, we'll talk about how sulfur exits the cycle. We'll talk about leaching. We'll talk about harvested material. And we'll talk about loss through the atmosphere. We'll then talk about how sulfur is tied up in the soil. And we will close this series by talking about how the sulfur story may be changing in the Midwest. But let's begin by talking about that basic information, the series theme, and how sulfur actually enters into the soil sulfur cycle. Now, sulfur is usually considered a secondary nutrient, so not a macronutrient or a micronutrient, but a secondary nutrient. It's present, though, within the plant at levels that are roughly equal by weight to the amount of phosphorus and magnesium in that plant. So 0.1 to 0.4% of the plant by weight. Now, just to give you some comparisons, nitrogen makes up about 1 to 5% of a plant by weight. Phosphorus, like I said, is that 0.1 to 0.4, as is magnesium. Potassium may be 4 to 5% of the plant by weight, depending upon the plant species we're talking about. And calcium is 0.2 to 1% of the plant by weight. Now, what does sulfur do, the function within the plant? Well, it's really important in the construction of amino acids. Think of those as being the building blocks of proteins, which are the building blocks of all sorts of things in the plant. And this is one reason why you get this yellowing symptom associated with a sulfur deficiency that kind of resembles nitrogen deficiency, because nitrogen is really important in the construction of amino acids as well. Sulfur is important for general plant growth and metabolism. We'll get back to that here in a second. And it's also involved in chlorophyll formation. Here again, nitrogen is too, and because it influences chlorophyll, that explains some of the yellowing. It's involved in root growth, it's involved in the processes that stimulate seed production, but it also is involved in enzyme activity. A lot of the enzymes in the plant actually have sulfur as a component of them, and that's the reason you see it influencing many of these things listed above. Now, I said that there are similarities between the symptoms of nitrogen deficiency and the symptoms of sulfur deficiency. There are similarities, but where they appear on the plant matters. Nitrogen's fairly mobile. It's going to show its deficiency on the lower part of a corn plant, the older part of the corn plant. Sulfur is less mobile within the plant than nitrogen is, and that means you're going to see more uniformity in that yellowing, although you may see a little bit more of that yellowing towards the top or the upper younger portion of the plant, in this case corn. Sulfur is taken into the plant as sulfate, a negatively charged molecule, and that's actually pretty important information. It explains some things about sulfur that we're going to need to know in later series. It also has these similarities to nitrogen as far as how it enters the plant. And so we're not just talking about similarities in how it functions within the plant, we're talking about similarities in how it enters the plant to nitrogen as well. And we'll continue to hear this story about there being these similarities to nitrogen. Now, from the soil side of things, sulfur makes up about 0.06 to 1% of the Earth's crust. It's readily leached from the soil. That has a little bit to do with that negative charge we mentioned on sulfate earlier. We'll talk about this more in series to come. But as far as its cycling in the soil, it cycles in a manner that has a lot of similarities, again, to nitrogen. You've heard that theme a few times now about these similarities to the way nitrogen behaves or cycles or performs. There are some things there we can use to kind of keep track of sulfur information as well. We've really talked up this idea of similarities to nitrogen. That really is true. If you look at the way that sulfur behaves in the soil, how it's brought into the plant, etc. There are a lot of parallels to nitrogen, but one big difference is that historically we've talked about fertilizing with nitrogen, but we really haven't talked about fertilizing with sulfur. And this is the reason why. There was some real definitive work, a batch of studies conducted between 1970 and 1979 at the University of Illinois, where they applied sulfur. There are 80 plus site years, and out of those, only 5 responded. The conclusion that the researchers came to was that while sometimes there were some responses, for the most part, we were getting enough sulfur through acid rain and through decomposing organic material to meet the crop's needs, and we therefore really didn't need to fertilize with sulfur. We were getting enough sulfur from other sources in a way that we didn't so much get with nitrogen. And this really became the direction, the guidance for the Midwest, that we really did not need sulfur, that it really was not necessary for us to fertilize for that nutrient. That was the story until recently. And some research that has recently been conducted leads us to the conclusion that the story may be changing. While it hasn't changed everywhere, and while we are still fairly confident that sulfur probably is not needed in most Midwestern fields, that cannot be said for all Midwestern fields anymore. Eventually, in Session 8, we're going to detail the most recent research that indicates what may be happening when it comes to sulfur, but for now, let's leave it there and let's start talking about the theme for this series. Now, this series will actually talk a lot about the soil sulfur cycle, and that cycle can look pretty confusing, and you may sit there and wonder, why in the world are we even looking at the cycle when it comes to sulfur? But it's for this reason. The soil sulfur cycle explains a lot of different things that we might have questions about when it comes to sulfur. And so the theme for this series is always, always, always look to the cycle. So here it is, the soil sulfur cycle. And right now I'm guessing as you're looking at this, some of you are actually a little bit anxious because you have circles all over the place with words in them and arrows pointing every which direction on this graph. But I want to encourage you to just calm down. It's going to be okay. Everything's going to be all right. We're going to take this complicated cycle and we're going to distill it down. So once again, the sulfur cycle can look incredibly complicated, but we're going to break it into sections, into bite-sized pieces to try and get you introduced to it, because it's going to help us understand a lot of the questions we have, the answers to a lot of the questions we have about this important nutrient called sulfur. We're going to talk about entering the cycle, sources of plant available sulfur as you look at this cycle, exiting the cycle, and how stuff gets tied up within the cycle. We're going to look at these pieces of the sulfur cycle as we discuss this topic. Now, as promised at the beginning of the session, we're going to close today out by talking about the different ways that sulfur actually enters into this complicated cycle. There actually are only 2 pathways into the soil for sulfur, 2 major pathways into the soil for sulfur, and we're going to talk about that. Once again, here's that cycle. You can see there are all sorts of different arrows again of things going out, things coming in, but if you look closely, you can see the pathways in to that cycle. Here they are, the 2 major pathways. You can have sulfur enter the cycle through sulfur fertilizer, so sulfate or elemental sulfur, or you can have sulfur enter the cycle through atmospheric deposition, falling out with rainwater. So there you have it. That's the end of session 1. We talked about our general theme, always, always, always look to the cycle. We said that helps us solve or answer some of the questions we might have about this nutrient. We talked about basic bits of information related to this secondary nutrient that we call sulfur, what it's used for within the plant. We talked about how much of the Earth's crust is made up of sulfur. And we talked about bringing sulfur in. How is sulfur brought in to that great big complicated cycle? We began this process of dissecting the cycle, showing these two pathways in through fertilizer or through atmospheric deposition in acid rain. Next time, we're going to talk about plant availability. We look forward to seeing you then at session number 2. And until then, tune into more sessions at Burris Agronomy U.